Right. So, good evening, students. Today we are going to discuss about orifice meter problems. Right. I'll read the question from problem 6.22, which is posted in our group. The question I read: an orifice meter with the orifice diameter 10 centimeters. Orifice diameter, that is orifice dia is equals to 10 centimeters, and is inserted in a pipe of 20 centimeter diameter. Pipe diameter D1 is equals to 20 centimeter, which is inlet diameter. You can see this diagram here. If it is orifice meter, this is reference 1, this is D1. Then here you can find that this is orifice, it's like a upper section. This dia is orifice dia, this is D0. This is orifice plate inserted in the pipe, so through which water is flowing. So this is orifice dia, this is inlet dia. Fine, these two are given. D0 is orifice dia, D1 is pipe dia, inlet dia. Fine, now the fluid is flowing from 1 to 2. This is 2, for example. Now in the question, pressure gauges fitted upstream and downstream of the orifice meters gives readings of pressure has given that P1 has given 19.62 newtons per centimeter square, and the downstream, this is upstream, this is downstream, that is inlet and outlet. Then P2 is 9.81 newtons per centimeter square respectively. Then coefficient of discharge for the meter is given as 0.6. CD has given 0.6. Find the discharge of water through pipe. Discharge means Q actual. We should find this Q actual. Friends, this is the given data. This is our flow meter, orifice meter. D1 has given, D2 has given. That, as you know, that this is solution starts from here. From D0 we can find A0. A0 is equals to pi by 4 D0 square. This is area of orifice. A1 is equals to pi by 4 D1 square. D1 is there, D0 is there. So I got A0, A1 and P1, P2 also given. So friends, our equation for CD or Q actual, let me write here only. Q actual is equals to, the formula is CD into A0 A1 root of 2GH by square root of A1 square minus A0 square. This is our equation to calculate Q actual. CD is there. A0, A1 also we found according to from the given D0 and D1. Here A0, A1 also there. 2GH, G is constant 9.81, H only unknown. Let me write here H value. As you know that H is equals to our equation X into Sg by S0 minus 1, or we have we don't know H value, that reading of manometer. We don't know specific gravity of mercury is constant, specific gravity of oil also we don't know. So to find H value, we have an equation, difference of pressure heads, P1 by rho z minus P2 by rho z. So P1, P2 has given, rho is the density of water, G is the gravity. So by using this equation, we can find H value. What is the P1? 19.62. What is the P2? 9.81. Substitute P1 19.62, rho is equals to density 1000, G gravity 9.81 minus P2 9.81 by density 1000, gravity 9.81. After substituting these P1, P2 in this equation, we find H value. Substitute H value in this equation, G value, A0, A1 and CD also given 0.6. Substitute the values and simplify, we'll get Q actual. Q actual will get in centimeter cube per second because of D1, D0 to D1 has given in centimeters, pressures are in centimeters. So every parameter is in centimeters. We'll find the discharge centimeter cube per second. But as you know that, so our discharge must be in meter cube or liters. So you know that convert the centimeter cube into liters. That is 1 by 1000 liters per second. The value what you got x, for example, that x into 1 by 1000 liters per second. Right, this is liter per second. Or if you want to calculate meter cube per second, the x value into 1 by 10 power 6 into meter cube per second. So these are the discharge values in centimeter cube per second, liter per second, meter cube per second. If you want to convert into liters, 1 by 1000, that into answer what you got. If you want to convert this into meter cube, your value into 1 by 10 power 6 meter cube per second. This is our required discharge through the orifice meter as per the given dimensions. So let us see the next question. The same problem 6.23 has given in the group itself. So we'll discuss in next video.